harmonic functions. Determine whether the following functions are harmonic. A function f of z is said to be harmonic if it satisfies the Laplace equation in the form of partial second derivative of f with respect to partial second derivative of x second derivative plus partial second derivative of f partial second derivative of y is equals to 0. So a function is harmonic if it satisfies this Laplace equation. And these Laplace equations can be written in Cauchy form, and it will be partial second derivative of u with respect to x plus partial second derivative of u with respect to y is equals to 0, or partial second derivative of v with respect to x plus partial second derivative of v with respect to y is equals to 0. So a function is harmonic if it satisfies either these equations. So our equation 1 will be determine whether or not the given function u, function of xy, is equals to e raised to the power negative y cos of y is harmonic or not. So a function is said to be harmonic if it satisfies the Laplace equation in form of partial second derivative of u with respect to x plus partial second derivative of u with respect to y is equals to 0. So partial second derivative of u from our given question with respect to x will be, we don't have our functions with x, so it will be 0. Partial second derivative of u with respect to x is 0 again. So partial derivative of u with y is equals to, you have two functions, e raised to the power negative of y cos of y. So you use product rule to differentiate. You differentiate e raised to the power negative of y, then you hold cos y, you add the derivative of cos of y, then you hold e raised to the power negative y. So derivative of e raised to the power negative y will be negative e minus y cos y minus derivative of cos y is minus sin y multiplied by e raised to the power negative y. So e minus y sin y, read together. So the partial second derivative of u with x will be, factor out negative. Negative is on both negativity. So you find derivative of e raised to the power negative y, negative e minus y cos y minus e minus y sin y. Sin y, that is this part, plus derivative of e raised to the power negative y is minus e raised to the power minus y sin y. This is negative sin y plus e negative y cos y. Read together. Cos y. So you open with the negative. You have e negative y cos cos y plus a negative y sin y plus a minus y sin y minus a minus y cos y. So e minus y and e minus y cos y goes. So the second derivative of u with respect to y will be, second derivative of u with respect to y will be e is the power y sin y plus e is the power minus y sin y. So 2 e minus y sin y. Check whether it is harmonic. So if it is harmonic, you add 0 plus 0 2a not equal to 0. So it is not harmonic. It's not harmonic. So example 2, u functions of x and y is equals to 1 over 2 natural log of x squared plus y squared. Determine whether or not this function is harmonic. And we have said that a function is harmonic if it satisfies the Laplace equation. So partial derivative of u with x is equals to half. You differentiate this part partially with respect to x. So you consider this part and you find derivative with respect to x is equal to x, isn't? Only part with the x partially divided by x squared plus y squared. This is equals to x over x squared plus y squared. Partial derivative second times of u with respect to x is equals to, you have x divided by x squared plus y squared, differentiated again, x over x squared plus y squared. I use quotient rule to differentiate. Derivative of x is 1 multiplied by x squared plus y squared minus x, derivative of this with respect to x partially is 2x divided by x squared plus y squared squared. This is equivalent to x squared plus y squared minus 2x squared y squared minus x squared all over x squared plus y squared squared. So you are done with respect to x. Partial derivative of u with respect to y is equals to half. You differentiate this part partially. The part containing y is 2y divided by this x squared plus y squared is equals to y all over y x squared plus y squared x squared plus y squared. You differentiate second times partial derivative of u with respect to y is equals to y divided by x squared plus y squared. It's in form of f of x divided by g of x. I use quotient rule. So derivative of y is 1 multiplied by this part, denominator part, y squared, minus derivative of denominator part with respect to y partially is 2y multiplied by y, 2y squared, divided by x squared plus y squared squared. So this is equivalent to x squared plus x squared plus y squared minus 2y squared is x squared minus y squared divided by x squared plus y squared over 2. You have this and this. Add them. We add them and check whether we will obtain 0. So y squared minus x squared divided by x squared plus y squared plus x squared minus y squared divide x squared plus y squared. You add them by finding the LCM. The LCM is this, they are equal. So x squared plus y squared of y squared minus x squared plus x squared minus y squared. 0 divided by x squared plus y squared is equals to 0. And hence it is harmonic since it satisfies the Laplace equation. Example 3. Determine whether or not the function is e raised to the power negative y sin x is harmonic, and a function is harmonic if it satisfies this equation: partial second derivative of v with x plus partial second derivative of v with respect to y is equals to 0. So partial derivative of v with x is equals to, so you differentiate the part with x only. So e minus y cos x partial second derivative of v with x equals to minus e raised to the power negative y sin x. So partial derivative of v with y, here now you differentiate the part with y, is equals to negative e raised to the power negative y sin x partial second derivative of v with respect to y is equals to e raised to the power y sin x. Check whether these are harmonic. So partial second derivative of v with x is minus e minus y sin x plus partial second derivative of v with y plus e minus y sin x is equals to 0, and it is harmonic since it satisfies the Laplace equation at this.